Hello guys, welcome to the Notorious Mechanical Engineers channel. This is your mechanical engineer, your friend Indrajit Nath, and today I'm here to teach you something about the GD&T basics, and we're gonna go through some of the important topics of GD&T, which every mechanical engineer or a designer should know about. And this is a channel which I have made so that I can impart my knowledge and share some of the interesting things about GD&T. You can go through my playlist and have a look at the other videos and have more insight on what actually the GD&T is all about. So without further ado, we will begin. So as a mechanical engineer, the fire within us should always be ignited and it should be always burning. So let the power of youth explode. Let's begin our class. So here in GD&T today, we're going to talk about feature of size and rules of GD&T. As you all know, GD&T, there are certain rules and regulations that one should follow, and today we're going to discuss some of them. So starting with the feature of size, what exactly is a feature of size? In GD&T, the term feature of size refers to one cylindrical, spherical surface or two opposed parallel elements, and it should always be with a dimension. Okay, these are actually the two two basic things that should be there always in order to make it a feature of size, whether it is a cylindrical part, spherical part, two opposed parallel elements with a dimension. Okay, with a dimension. So you can make out what all dimensions are feature of sizes, but there's an easier way to find out what exactly are the feature of sizes. The key part of the feature of size definition is that the surfaces or elements must be opposed. Okay, so a feature of size can be determined by using some of the key elements, or you can say key fundas that you can use to figure out which all are the feature of sizes. So here you can see like the it contains opposing elements or surfaces. Like here you can see the slot length. Okay, it is a feature of size. Here the width of the plate, it is a feature of size. The thickness of the plate is a feature of size. Okay, it can also be determined if you can establish an axis, a median plane, or counterpoint. Okay, sorry, not counterpoint, center point. So if you can establish an axis, suppose a hole is there or a cylinder is there. Okay, if you can establish an axis, then the size that you have given to that feature is actually called as the feature of size. If you can establish a median plane, it is called a feature of size. Okay, so these all are feature of sizes that you can make. Okay, what all are feature of size, you know, but you should also know which all are not feature of size. So here if you see, the dimensions which are made in red are actually not feature of size. Okay, these are not feature of size only because these are not opposing elements. Okay, these are not opposing elements. You cannot measure it with regular measuring devices like vernier calipers. Okay, so these are actually not a feature of size. And there are two types of feature of sizes that are there. One is internal feature of size, one is external feature of size. Very simple way of remembering is that whatever feature is there that is inside the part, which is inside the part, and you can measure it. That is actually the internal feature of sizes. Basically holes, your slots, all the cutouts that come inside the part are those, the dimensions that are mentioned with them are actually the feature of size, internal feature of sizes. So what are external feature of sizes? Simple, whatever dimension that is measured outside the part. Okay, externally, suppose there was also a pin, a small pin that was extruding over here. Okay, or protruding over here, that would have been an external feature of size if that diameter was given with the dimension. Okay, so that would have been an external feature of size. This is an external feature of size, this is an external feature of size. Okay, hope that makes it clear. Okay, we'll now move on to the rules of GD&T. This is very important actually. So the rule of GD&T, the first rule says individual feature of size rule. You have to know this is the feature of size rule. It is also called as envelope principle or perfect form at MMC. This one, the second one, is actually the best way to remember it. The first rule is the perfect form at MMC. perfect form at maximum material condition. What exactly it tells you? It actually tells you that at maximum material condition, the form, the shape of the part will be exactly perfect. Okay, we'll come to know with the following examples here. So, okay, this rule states that where only size tolerance is specified for a regular feature of size, wherever a size tolerance, basically size tolerances are nothing but a dimension given with a plus or minus, tolerance given to it, or limit tolerance is given to it for a regular feature of size. The limits of size also controls the form. So whatever the limits that are mentioned, that actually controls the shape of the part also. So here if you take an example, here taking an example of an external feature of size, suppose we take a shaft or a pin. Here we see that it has a maximum material condition of 10.8 and a minimum material condition of 10.6, maximum material of 10.85, because at that dimension of the shaft it will have the maximum weight and it will have the maximum material. That's how you should remember it, that it will be a maximum material condition at 10.8 for a shaft. That will be the heaviest, will have the maximum material. So what will happen here is that uh, you can take a hole of 10.8, the maximum material condition, and you can actually imagine this part within this range can pass through this. Okay, you can pass through this. That will be an acceptable part. If someone produces a part which is beyond this range, it will not be acceptable. Okay, in that there is a catch. If you consider a part which is made exactly 10.8, you will see that it will exactly fit here without any deviation, without any change in its shape. Okay, that's what this perfect form at MMC is all about. So there will be a perfect form if you make this part with 10.8 diameter shaft. This will exactly form here, and it will be of a perfect shape, and it will be hence called as a perfect form at MMC. Okay, so this will be the perfect form at MMC. So MMC size and boundary condition, it will pass through this 10.8 no matter what, if it is a passable part. Okay, so but also it has to satisfy the LMC size limit condition. Whatever cross section you take over here, any cross section at any point, it should not go below 10.6 mm. It should be always greater than 10.6 mm. Okay, because that was my limit. But actually you can, but the gauge that you will be making will be of this maximum material condition one. Okay, for a shaft. Here you have we have taken an example of internal feature of size. Here the hole is hole with a limit of 14 and 14.6. Maximum material condition will be at 14.0, because if I get a part with a hole with a diameter of 14 mm, suppose, it will be of higher mass, it will have more material than compared to 14.6 mm. Hence 14 will be the maximum material condition. Remember that. That is the way you should remember maximum material condition. Now in this scenario, if I take a cylinder of maximum material condition 14, okay, and suppose if I am able to manufacture a part, okay, if I am able to manufacture a part whose whole diameter is exactly 14, okay, it should always, if it has to be passable, it has to always pass through this, and it will form a perfect shape of this hole, or cylindrical hole you can say. It will make a perfect form at MMC, hence the name perfect form at MMC. Guys, you have to remember this. That's how they make it, the perfect form at MMC. Now also, just like the above case, in every cross section, it should not go beyond 14.6. That is the limit. Okay, that is the lower material least material condition limit. It should not pass this. So this is your basic rule. So basically what it tells is that the perfect format MMC, okay, the size tolerance actually controls, my bad, sorry guys, the size tolerance, whatever the size tolerance is mentioned in the part, it will actually control the form of the part, the shape of the part. You should remember that. Okay, going back to the second rule. So here in the second rule, it is very, very, very easy, guys. Here it is telling us about the regardless of feature size. As the name itself tells us, regardless of feature size. Okay, regardless of feature size means the tolerance will be applied regardless of the size of the feature. Here if you uh, take this whole, you have, if you don't have any modifiers here, it will be a regardless of feature size, guys. This is one way to remember it for the GD&t symbols. And every dimension is actually RFS. The tolerance that has been given is regardless of feature size. Okay, here if you take the example here, suppose the part has been produced with any part has been produced like 5.95, 5.98, 6.05, within the range of 5.9 and 6.1, it will actually have a tolerance of 0.02 of position tolerance. Whatever part that has been produced in between them, that is what the definition exactly says, indicates a geometric tolerance applies to any increment of size of the feature within its tolerance size tolerance. Okay, as another way to visualize RFS is that the geometric tolerance applies at whatever size the part is produced, whatever size, it will actually take the tolerance which has been given over there. Okay, and there is no symbol for RFS. There is no symbol for RFS here. I hope you got this point, guys. So these are the two basic rules of the GD&T. Keep watching the channel and keep subscribing, keep liking, so that I can post more videos. Check out my other videos as well, and keep sharing this knowledge, keep spreading this knowledge about GD&T and learn more, and let the power of youth explode, guys. We are all mechanical engineers. Let's rock and roll. See you guys again. Have a great day. Bye bye.